Alright, so here's the last of the equilibrium problems in these videos, okay, and then the rest will be for homework. So, um, in this problem, there are again two strings. The one of the strings is horizontal, the other one makes an angle of theta to the horizontal, and our goal again is to calculate the tensions T1 and T2. The system is in equilibrium. Okay, so what I suggest you do at this point is draw the free body diagrams, okay, and then set up the equations and solve. Go the whole way. Find T1 and T2. Now, the only restriction is that your answers can only be in terms of the mass m and the angle theta. So your answer can have nothing other than mass m, angle theta, and acceleration due to gravity. Okay, which is a constant. Okay, so those are the only things that you can have in your answer. Make sure that you have nothing else. Okay, so go ahead, solve the whole thing, and pause the video at this point, and then come back, and then we'll go through the rest, or we'll go through the problem, and you can check your work or figure out if there are any issues. Okay, all right. All right, so I'm assuming that you did that, you paused, and you finished the problem. So I'm just going to go through this very quickly. So first thing is draw the free body diagram. So there are forces. So we have T1 pointing in this direction, we have T2 pointing in this direction, and then we have mg pointing down. Okay. Once I have my forces, what we can do is we can break T1 into components. T2, we do not need to break into components because T2 is already pointing along the x direction. So the components of T1, if the angle is theta, are going to be T1 cosine theta, and then this one will be, will be T1 sine theta. All right. So now at this point, we have the components, and we can go ahead and try to write down our equations. So my equation along the x-axis, okay, is going to be T1 cosine theta minus T2 is equal to 0. Along the y-axis, the equation is going to be T1 sine theta minus mg is equal to 0, because those are the only two forces along the y direction. Okay, so now the the second equation, the equation along the y direction, gives us T1 directly, and T1 ends up becoming mg over sine theta. So solve this and make sure you get this. Once we have T1, we can now plug the value of T1 into equation 2, which is T2 is equal, or rather equation 1, which is T2 is equal to T1, which is mg over cosine theta, sorry, mg over sine theta, multiplied by cosine theta, which we can write as mg times cotangent of theta. Okay, so if your answers for T1 and T2 match, then great job, which means you seem to have a solid understanding of equilibrium problems, and then you can go ahead and finish homework and take care of stuff. All right, that's it for this video.